Hello friends, welcome back. So up to now we have covered everything up to clamper circuits. So in the diode circuits there is only one topic remaining, that is Zener diode. So what I will do is, first I will explain the difference between Zener diode and normal diode. After that I will explain how we will use Zener diode as an voltage regulator circuit. So let's proceed. So guys, this is the representation of the Zener diode, while this is the representation of the normal diode. So you can identify which is Zener diode and which is normal diode in question paper by this representation. So this is important, remember this. Next, if you see the characteristics of the normal diode, while applying reverse bias across normal diode, it will act as open circuit from here to here. And if we still increase the reverse voltage, at some point temperature will become very high and that normal diode cannot withstand this much temperature. So breakdown occurs. What is the meaning of breakdown? It is damaged. It cannot be used as a diode again. It is already damaged. Why it is damaged? Because we increased the reverse bias voltage in such a way that temperature is increased heavily. So breakdown has occurred. But while coming to Zener diode guys, that thing will not happen. Why? Zener diode can withstand high temperature. So in this way Zener diode is manufactured. It will conduct currents in the reverse bias also. See, if you consider normal diode, if you apply reverse bias, it will act as open circuit. It will not conduct any current. It will act as off switch. But if you consider Zener diode and apply reverse bias across it, it will also act as open circuit like this. So what is the difference? Difference will come when we increase the reverse bias voltage greater than this breakdown voltage. So across normal diode, whenever V reverse bias is greater than V breakdown region, breakdown occurs and the diode will damage completely. But while coming to Zener diode, whenever the reverse voltage is greater than VBR, breakdown will not occur. Why? It can withstand the high temperature. So consider this is the breakdown voltage of Zener. Whenever V reverse voltage is greater than Vz, the Zener regulates the voltage at Vz. It means that it stays at Vz and it conducts current here. So this is called as Iz minimum. This is called as Iz maximum. So when will the breakdown occur for Zener voltage? So what you did is you applied some reverse bias voltage. It is an open circuit. So whenever the reverse bias voltage is greater than Vz, it regulates the voltage to Vz. It is in breakdown region now. So only in breakdown region voltage across Zener diode will be equal to Vz. Before breakdown, it acts as open circuit, normal diode. So in forward bias, when positive voltage is applied to the Zener diode, it acts as normal PN junction diode. So during forward bias, Zener diode acts as normal PN junction diode. And when the voltage is less than Vz, it acts as open circuit before Vz. When the reverse voltage is greater than Vz, then it limits the output voltage across the diode. So when V is greater than Vz, Zener voltage is limited, means regulated. It is regulated to Vz and it will conduct the current. So what happened is it started conducting current. What we did, we increased the voltage more. So the current came from here to here and we increased the voltage again. The current reached Iz maximum. If we increase the voltage again, then the Zener diode will be in breakdown. Not in breakdown, it is already in breakdown. The Zener diode will damage. So it can withstand up to here. After this it cannot withstand. But what about the diode, guys? It will damage here only. But Zener is withstanding temperature up to here. So this is the specialty of Zener diode. So in short form, how can I say is Zener diode conduct significant current in reverse bias condition also. So this is the specialty of Zener diode, guys. So this is the overview. When Zener diode is in forward bias, it will act as normal PN junction diode. But when Zener diode is in reverse bias, there will be two cases. If the reverse bias voltage across Zener is less than Vz. What is Vz? Zener voltage, or it is also called as breakdown voltage. So VR less than Vz means here to here. It acts as open circuit. But when VR is greater than Vz, when VR is greater than Vz, the voltage across Zener is regulated to Vz. It will not change. It regulates the voltage to Vz till Imax is reached. If we increase VR more, the current through the Zener will increase. But the Vz is limited, regulated. So when current crosses the Iz max, it will damage. So this is called as knee current, guys. So if you consider forward bias, it is acting as a normal PN junction diode. There is no specialty of Zener diode. But if you consider reverse bias condition, when V is greater than V breakdown, the normal diode will damage. But the Zener diode will limit the voltage or regulate. So to use Zener diode as a voltage regulator circuit, we should operate it in reverse bias and at breakdown region. We should apply reverse voltage greater than Vz so that the Zener diode will regulate the voltage. So this is the main idea from where the voltage regulator had born. See, the main purpose of the Zener is to conduct current in reverse bias only. Why? It is the specialty of Zener diode. In forward bias, the normal diode will also behave in same condition. But in reverse bias only, the specialty of Zener will come into picture. That too, whenever reverse voltage is greater than Vz, which is breakdown voltage, normal diode will damage, but Zener diode will limit the voltage. So I am telling it again and again. Why means it is very important, guys. Remember. So equivalent circuit of Zener diode. See, when it is in forward bias, it will act as normal PN junction diode. So what will be equivalent circuit? If there is the direction of current, the voltage should oppose and some internal resistance. This is the equivalent circuit. But while in breakdown region, what will be the equivalent circuit? The same voltage will appear, but the voltage is negative here, that is minus Vz, and some internal resistance. So this I can write in this way, Vz. So if you observe here, guys, see, this is the representation of the Zener diode. In the breakdown region, this is the equivalent representation. So we are drawing Vz in the same direction of the Zener diode. So don't confuse with diode and Zener diode, guys. In diode forward bias, we will be drawing this voltage in the direction opposite to the Zener notation. But here we are drawing this voltage in the same direction of the Zener notation. Why? Because it is operating in reverse bias. So forget all things, just remember these two. Whenever reverse voltage is greater than Vz, it will operate in breakdown region. In breakdown region, it will limit the voltage to Vz or regulate the voltage to Vz. So this is the equivalent representation of the Zener diode under breakdown region. Is it okay, guys? So guys, next concept is how we will use Zener diode as a voltage regulator. Whatever be the change in input voltage, whatever be the change in load resistance, but our load voltage should remain constant. This is the basic idea of the voltage regulator. So how we are using Zener diode as a voltage regulator? If you observe carefully here, this load voltage is parallel to the Zener diode. So if Vz is fixed, load voltage is also fixed. Will you agree with me? If Vz is fixed, load voltage is also fixed. So for fixing the Vz, what we should do? We should apply reverse voltage which is greater than Vz. We should operate the Zener in breakdown region. Then only the voltage Vz is fixed. So this is all about the voltage regulator. So guys, now we will analyze it step by step. So we should make Vr greater than Vz, reverse voltage. For that, what we should do? First I am drawing the equivalent circuit here, guys. This is R, this is RL. This is our input voltage Vi. So voltage across Zener. I am calling this as some Vr because see it is P terminal, it is N terminal. We are applying the reverse voltage. So I am calling this as Vr. So what will be Vr equal to? Vi into RL by R plus RL. Is this okay, guys? So whenever Vr is greater than Vz, Zener regulate the voltage to Vz. So whenever Vr is greater than Vz, what is the equivalent circuit across Zener, guys? Since Zener is pointing in this direction, equivalent circuit is like this. This is the load resistance, let it be source resistance, and Vi. So this is the equivalent circuit of Zener and this voltage is Vz. Now see here. Change the input, change the load resistance, but the voltage will not change. Why? It's the property of the Zener to limit the voltage to Vz. So guys, now you got when the Zener diode will be operated in the breakdown region and how we are using this as an voltage regulator, right? Now what I am doing is I am considering the Zener diode is in breakdown region. That means it is limiting the voltage to Vz, and I will analyze three cases. So these are the three cases, guys. When Vi and RL both are fixed, when Vi is variable, RL is fixed, and when Vi is fixed and RL is variable. So I will analyze these three cases, and there is also another case where Vi and RL both are variable. I will also teach about this and I will solve problems on this fourth case. This is very important. So first I am talking about this case. See, Vi and RL are fixed and Zener is in the breakdown region. So what is the equivalent circuit? This is the equivalent circuit. R, RL, Vi, this is Vz. Now, what will be input current? Since it is the input voltage is Vi, input current I equal to V input minus Vz by R. What will be load current? Vz by R. Since Vz is equal to V0, load current is equal to Vz by R. See, this Vz is equal to V0. So what will be Zener current? I minus IL. If you apply KCL here, input current is I, output current is Iz and IL. So Iz will be equal to I minus IL. What is I? V in minus Vz by R. What is IL? Vz by RL. So what is Iz? I minus IL. So this is the normal condition when Vi and RL are fixed. We will go to the next case. So in this case, if you observe, he gave that RL is fixed. So we will fix this load resistance and Vi is variable. So since it is variable, I am taking Vi minimum to Vi maximum since the input voltage is variable and load resistance is fixed. Since Zener is in breakdown region, what will happen, friends? It limits its voltage to Vz. This is the voltage Vz. Since Vz is fixed, RL is fixed, so output current is also fixed. IL is also fixed. First case, I am considering V input minimum. If V input is minimum, what is the value of I? I is V input minus Vz by R. If you observe here guys, R is constant value and Vz is also constant value. If V input is minimum, I will be minimum, right? And what is I maximum equal to? V input maximum minus Vz by R. This is the V input minimum, this is the V input maximum. So since Vz and R are constant, if V input is minimum, here current I will be minimum. If V input is maximum, here current I will be maximum. What is the first point? Load current is constant, and here minimum and maximum current depend upon the input voltage. Now we will analyze the Zener current Iz. Since Iz equal to I minus IL. If you observe here guys, IL is a constant value. So Iz completely depends upon the input current. If input current is minimum, Iz will be minimum. If input current is maximum, Iz will be maximum. So I am writing here Iz minimum equal to I minimum minus IL. So what is I minimum? I minimum is this. When will you get I minimum? When we apply V input minimum. So when the input voltage is minimum, we will get minimum Zener current. Similarly, when the input voltage is maximum, we will get maximum Zener current. So this is the second case guys. Now we will move to the third case. So in this case, input voltage is fixed and load resistance is variable. So I am considering the load resistance between minimum RL minimum to RL maximum. Now we will analyze this circuit. What will be the equation of the current I? I equal to V input minus Vz by R. If you observe here friends, R is a constant value, Vz is a constant value, V input is also constant value. So the input current will be constant. Next, if you observe load current guys, IL is Vz by RL. So whenever RL is minimum, IL will be maximum. Similarly, whenever RL is maximum, IL will be minimum. Next, let me write the Zener current Iz. This is I, this is IL, this is Iz, Zener current. So Iz is nothing but I minus IL. If you observe here guys, whenever IL is minimum, Iz is maximum. And whenever IL is maximum, Iz is minimum. I am writing these two conditions from this equation. So what is the value of Iz minimum? I minus IL maximum. I is a constant value. And what is the value of Iz maximum? I minus IL minimum. Since I is a constant value, Iz totally depends upon the IL. So what is happening is guys, when is the IL maximum? When the load resistance is minimum. When will be the IL minimum? When the load resistance is maximum. So Zener current will be minimum whenever the load resistance is minimum. And Zener current will be maximum whenever the load resistance is maximum. So this is the third case guys. If you see this question guys, he gave a circuit. Find Iz, IL and V0. This is the Iz, this is the IL, and this is V0. He's asking us to find these three parameters, and it is given that breakdown voltage of Zener is 6 volt. So what is the first step we should do? We should check the voltage across Zener. For that, open circuit the Zener diode. It is 10 volt, it is 1 kilo, it is 0.5 kilo. So what is the voltage across Zener? 10 into 0.5 by 1 plus 0.5. That is, 1 plus 0.5. 0.5 by 1.5 into 10. That is equal to 3.33 volt. See, this is P type, this is N type. We are applying voltage in reverse direction, so it is in reverse bias condition. But if you observe here, if it is the graph of reverse bias condition, this is Vz. He given Vz equal to 6 volt. So whenever reverse voltage is greater than Vz, it will limit the voltage to 6 volt. Whenever reverse bias voltage is less than 6 volt, it will operate as open circuit. So what is the reverse bias voltage here? 3.33 volt. So it will operate as open circuit only. So now what is the answer? Iz equal to 0. IL equal to 10 by 1.5 kilo. That will be 6.67 milliampere. And what is the output voltage V0? 10 into 0.5 by 1 plus 0.5. That is 3.33 volt. So friends, don't think that every time the Zener diode will operate in breakdown region. Sometimes it will operate in open circuit region, and sometimes it will operate in short circuit. Sometimes it will operate in off condition, sometimes it will operate in on condition also. Not every time in breakdown. So whenever the reverse voltage is greater than Vz, then only it will operate in the breakdown and it will limit the voltage to Vz. So if reverse bias voltage is less than Vz, it will operate as open circuit. So remember this, guys. Similarly, if you observe this question, guys, what will be voltage across Zener? 10 into 1 kilo by 1 kilo plus 0.5. That is equal to 6.67 volt, which is greater than Vz. So if you observe the graph here, this is the Vz. The applied reverse voltage is greater than Vz, so it is operating in the breakdown region. So what is the equivalent circuit of Zener under breakdown? This is the equivalent circuit. It limits the voltage to 6 volt. Now what is he asking? Find Iz. First we will find IL. IL is nothing but 6 by 1 kilo, that is 6 milliampere. Next, input current is nothing but 10 minus 6 by 0.5 kilo, that is 8 milliampere. So input is 8 milliampere, load current is 6 milliampere. What will be Iz? That is 2 milliampere. And what is the output voltage? 6 volt. So output voltage is regulated to 6 volt. If you observe this question, guys, he given that Iz minimum is 10 milliampere and Iz maximum is 60 milliampere and Vz is 10 volt. So find required range of input for the satisfactory operation of the circuit. So this is basically a voltage regulator circuit. What is meant by satisfactory operation? The voltage should be regulated under all condition. So voltage should be regulated indirectly it means that Zener diode should be in breakdown under all conditions. I am repeating it, guys. This is a voltage regulator circuit. Satisfactory operation of the circuit mean the voltage should always be regulated. That indicates that Zener diode should always be in the breakdown region. So if Zener diode to be in the breakdown region, if you see the graph here, characteristic here, this is Iz minimum. This is Iz maximum. If the current is less than IZ minimum, it operates as open circuit. So the satisfactory operation fails. If the current is greater than IZ maximum, it will damage. So here also the satisfactory operation will fail. So for the circuit to be in satisfactory operation, the Zener diode current should be in between IZ minimum and IZ maximum. So he given the minimum current and maximum current. The current should lie between 10 milliampere and 60 milliampere. That's it. Find required range of input for that. See, input equal to IZ plus IL. What is the VZ guys? 10 volt since it is in breakdown. So what is the IL? 10 milliampere. So IL is constant. If minimum current is 10 milliampere, what will be input minimum current? That is 10 plus 10, that is equal to 20 milliampere. Next, what is the input maximum current? That is IZ maximum plus IL. So what is IZ maximum? 60 milliampere. IL is 10 milliampere. So this is 70 milliampere. So what is the equation of current? V input minus Vz by R. R is 300 ohm. See, if you consider I minimum, you will get Vi minimum. So calculate Vi minimum. And similarly, if you consider I maximum, since Vz is a constant value, you will get Vi maximum. You will get Vi maximum. I am not solving this guys because it is very easy. So this is the required input range to keep the diode current between IZ minimum and IZ maximum so that the circuit will operate satisfactorily. So he has given a circuit and asking us to find worst case value of R for satisfactory operation of the circuit. So guys, now you know what is the meaning of satisfactory operation of the circuit. And using that resistance, calculate the maximum power dissipation. See, here he mentioned knee current is. So knee current is nothing but IZ minimum. So this is called as the knee current guys. Knee current is nothing but the IZ minimum current. So in the question he mentioned the minimum current. So for satisfactory operation of the circuit, what are the condition guys? IZ should be greater than IZ minimum and IZ should be less than IZ maximum. So if IZ is in between IZ minimum and IZ maximum, this Zener diode will operate in breakdown region and the voltage regulator circuit will work. So this is the basic condition. Since in the question he mentioned IZ minimum, now this is the condition. If you see here, input voltage is varying. He is asking the worst case value of R. So if you see I equal to IZ plus IL. If you observe here guys, if IL is maximum, IZ will be minimum. And if IL is minimum, IZ will be maximum. Since he is asking worst case value of R, we should take IZ minimum. And we should take IL as maximum. So worst case is nothing but critical. What is critical? It is operating at the edge point. So this is the edge guys. It is operating at the edge point. At the edge, IZ is minimum. So what will be IL? Obviously it will be maximum. Next, while coming to I. So you have two values of I. One value you will get with 20 volt. Another value you will get with 30 volt. So with 20 you will get I minimum guys. With 30 you will get I maximum. So which value you should take? He is asking worst case. See, if you take I maximum, If you take I maximum, IZ will also be maximum. Like when compared to this, it will be maximum. If you take I minimum, IZ value will also be minimum. Since he is asking the worst case, we will choose this case. IZ is not maximum, guys. It will be more if I is more. If I is less, IZ will be less. It is not maximum. So since it is worst case, we will consider this I minimum equal to IZ minimum. So we will consider I minimum. Because we need the minimum Zener current, because it is operating at the edge, critical value. So for minimum I, consider 20 volt. So what will be I? 20 minus, what is VZ? 10. 10 by R. That is 10 by R. Equal to what is IZ minimum? 10 milli. Plus what is L maximum? 100 milli. So R equal to 10 by 110 milli. So that is 1 by 11 kilo ohm. That is the value of R. So this question is completed. I am removing all this. By using that resistance, calculate the maximum power dissipation. So maximum power dissipation is nothing but VZ into IZ. So maximum power dissipation across Zener diode he is asking. So power dissipation is VZ into IZ, guys. What is the value of VZ? It will be constant. What is the value of IZ? It will vary between minimum and maximum. So for maximum power dissipation, we should consider VZ maximum. So VZ into IZ maximum. Is this okay, guys? So if you see here, I equal to IZ plus IL. For IZ to be maximum, IL should be minimum. Next, for IZ to be maximum, this I should also be maximum. So we are considering 30 volt here. So if I consider 30 volt, 30 minus 10 by R equal to IZ maximum plus IL minimum is 0. From this what I am getting? 30 minus 10, 10. 20, so 30 minus 10, 20. So IZ max is 220 milliampere. This is the value I am getting. So what will be power dissipation? VZ. What is VZ? 10 into IZ max. IZ max is 220 milliampere. So this is 2.2 watt. Guys, if in the exam he asked power rating, power rating always corresponds to the maximum power dissipation. There is no concept like minimum power rating and maximum power rating. So for confusing, he will ask what is the minimum power rating. So what you will do is you will consider VZ into IZ minimum. That is wrong, guys. There is no concept like minimum and maximum power rating. Power rating itself indicates the maximum power dissipation. So if we mention power rating in the question, always consider the maximum power dissipation. Don't take minimum current. So remember this. So if you observe this question, guys, he is asking the output voltage V0. So if this leg is in off condition, then output voltage V0 will be equal to 10 volt because it is in parallel. If this leg is in on condition, then we should check the output voltage. So first what we will do is we will open circuit the leg completely. 10 volt, 1 kilo ohm. See, I open circuited the leg. For this leg to be in on condition, this Zener diode should be in forward bias because positive is connected to P terminal, negative is connected to P terminal for this Zener diode. So this should be in the reverse bias. So for forward bias, what is the equivalent circuit, guys? We should draw voltage in opposite direction. and he mentioned V gamma is 0.7 volt. And Vz is 5 volt. Next, this Zener to be in reverse bias. So what is the equivalent circuit, guys? So this is the equivalent circuit. This is 0.7 volt. This is 5 volt. So total voltage is 5.7 volt here. If V input is greater than 5.7 volt, then it will be in on condition. If you check here, V input is greater than 5.7 volt. So it is in on condition. So what will be output voltage, guys? Output voltage is limited to 5.7 volt. That's it. If you observe this question, guys, for this leg to be in on condition, this Zener should be reverse biased. And this Zener should also be in the reverse biased. Then only this leg will be in on condition. If this leg is off, V0 will be equal to 10 volt directly. If this leg is in on condition, then we should check. So first what I am drawing is I am open circuiting the Zener diodes. So this is 10 volt. I open circuited this. So I will draw the equivalent circuit. And Vz equal to 5.7 volt. V gamma equal to 0.7 volt. See, this Zener diode to be in the reverse bias. What is the equivalent circuit? 5.7 like this. And for this Zener diode, 5.7. This is the equivalent circuit. So total voltage is how much? 10, 11.4. So if input voltage is greater than 11.4, then this leg will turn on. Since input voltage is less than 11.4, this will remain in the off position and V0 will be equal to 10 volt because this is the circuit directly. This leg is in off position. V0 is directly equal to 10 volt. So see this question, guys. He given Vz equal to 5 volt. It is an ideal diode. Find the output voltage. See, if you observe in positive half cycle, positive is connected to the N type. So this Zener diode is in reverse bias. So in reverse bias condition, this is the equivalent circuit. Here the voltage is 0. Here the voltage is Vi. So what is the voltage across Zener diode? Vi minus 0, that is Vi. Vi is the voltage across Zener diode. So whenever Vi is greater than 5 volt, what will happen? Zener diode will enter into breakdown region. Whenever Vi is less than 5 volt, what will happen? It will remain as open circuit. So whenever Vi is less than 5 volt, this is the condition, guys. This is the equivalent circuit. So V0 will be 0. But whenever Vi is greater than 5 volt, it will enter into breakdown region. So what is the equivalent circuit in breakdown region? This is the equivalent circuit, guys. This is 5 volt. This is Vi. So V0 will be equal to Vi minus 5. Next, it is for positive half cycle. While coming to negative half cycle, since minus is connected to N type, it acts as the just normal diode. So it will be in forward bias like this. What will be V0 equal to Vi? So in positive half cycle, when Vi is less than 5 volt, V0 is equal to 0. Positive cycle, Vi less than 5 volt, V0 is equal to 0. When Vi is greater than 5 volt, V0 is equal to Vi minus 5. And while coming to negative half cycle, V0 equal to Vi. That's it. And this is the last question, guys. In this, a diode and Zener diode combination is given. Which diode? Normal diode and Zener diode. So he gave the input voltage and he is asking us to find the output voltage. If you observe here, guys, if the two legs are not in operation, then V0 will be directly equal to Vi. V0 will change whenever either this leg or either this leg are in operation. then only our V0 will change. So first we will see during positive cycle. So during positive cycle, if you observe this diode here, let me draw equivalent waveform. See, during positive cycle, this diode is connected to the positive and this is connected to the negative. So for diode to be, this is the equivalent circuit of the diode for forward biased condition. This is 4 volt and this is 0.7 volt. So the applied voltage here should be greater than 4.7 for the diode to be in forward bias. If you observe Zener diode here, the applied voltage here, this is 6 volt. The applied voltage here should be greater than 6 volt for the Zener diode to be in breakdown region. So now we will see. We are increasing the input voltage. Let us say that at Vi equal to 4.7 volt or Vi greater than 4.7 volt. This leg is turned on. So during positive half cycle, when Vi is less than 4.7 or equal to 4.7, V0 is equal to Vi. When Vi is greater than 4.7, this branch is turned on. So what will be V0 now? Since this branch is turned on, here voltage will become 4.7. Voltage is regulated to 4.7. V0 will be equal to 4.7. So if you observe here guys, if this branch is turned on, this voltage is regulated to 4.7. So what will be the voltage across Zener? It will also be 4.7 volt. It indicates that Zener will remain in the off position. See, here voltage is 4.7 volt. But the Zener to be in breakdown region, the terminal voltage should be greater than 6 volt. But it is limiting, this diode is limiting this terminal voltage to the 4.7 volt only. So Zener diode will always be in the reverse bias, that in open circuit condition. And V0 will be equal to 4.7 volt. This is under positive cycle. While coming to negative cycle, so this is the equivalent circuit of negative cycle guys. This is the Vi applied. So here will be minus, here will be plus. Since we are applying negative to the P type of diode, this diode will remain in the off state. And we are applying negative to the N type of Zener diode. So this Zener diode is forward biased now. Its equivalent circuit is like this. Since it is in forward biased, sorry, this is wrong. It is in forward biased condition. So this is the equivalent circuit across Zener diode. So now what will happen? Whenever V input is greater than 0.7 volt in negative direction, then Zener diode will be in forward biased. So whenever V input is less than 0.7, V0 is equal to Vi. Whenever V input is greater than 0.7, V0 is limited to minus 0.7. So here V input is less than minus 0.7 means like 0.4, 0.5, 0.6 volt guys. Don't take in mass notation. And whenever V input is greater than minus 0.7 is 0.8, 0.9 these voltages. Don't take in mathematics notation. So whenever V input is less than 0.7, this Zener diode will be in the, this Zener diode will not turn on and V0 will be equal to Vi. Whenever V input is greater than 0.7, this Zener diode will be in the forward condition, forward bias condition. I mean in on state. If it is in on state, V0 will be equal to minus 0.7. So that's it guys. If I draw the equivalent graph here, see, whenever V input is greater than 0.7 in the positive cycle, the output is limited to 0.7. Whenever V input is less than 0.7, V0 is equal to Vi. And while coming to the negative cycle, Whenever V input is less than 0.7, V naught equal to Vi. But whenever V input reaches 0.7, V naught is limited to 0.7. So this is the output waveform. That is 4.7. This is 0.7. So in this lecture we have practiced a lot of questions, guys. So with this the total diode circuits are completed. If you like my explanation and you are learning something out of my channel, then subscribe to my channel, guys. It will really motivate me to do more videos, because if you are subscribing I will think that someone is learning something from me, then I will get more motivated to teach. So guys, if you see here, this topic is completed, guys. I have solved all the get previous year question with complete concept. From the next lecture, we will start the transistor circuits. That is, what is BJT, what is FET, how we will bias, how we will use that as amplifier, and all that, input resistance, output resistance, everything. So I will explain in very short manner. Like if I gave you a circuit, you can write answer directly without writing any equivalent circuit. By just seeing the circuit, you can write the output voltage or voltage gain directly just by seeing the circuit. In that way, I will teach this transistor circuits and amplifier circuits. That is transistor as an amplifier circuit. So that's it, guys. Meet you in next lecture.